Okay, this is problem number 2. And so we have the graph. So let me just draw that in. It's in your book. So what we have is a line, it's a line segment drawn like this. And we want to rotate around the y-axis. And this is point 2, 0. This is actually I'm looking at the wrong problem. This is point 1, 0, and this is point 0, 1. And the function, this line here is just y equals 1 minus x. And because we're rotating around the vertical axis and they're asking us to use the shell method, we want to have our representative rectangle as such, so that the rectangle is parallel to the axis of rotation. This one's in this direction, this is the same direction. And what we end up with is rotating around the y-axis, we have that as our radius. So that's the radius, so that's p of x. And then h of x is the height of the rectangle. So the height in this case, because the bottom is just going to be y equals 0 and the top is y equals 1 minus x. So h of x, the height of the rectangle through the entire domain, or the entire, notice I take this rectangle and it runs into this side on the left-hand side, and then it runs into this corner right there. And we are integrating with respect to x, because we draw our arrow perpendicular here, so we're integrating with respect to x. Anyway, so our function h of x and p of x have to be in terms of x. We have 1 minus x, basically minus 0. The inside is just the x-axis. So this is, remember the x-axis is also the line y equals 0. This is the y-axis is the line x equals 0. So anyway, that's h of x. It's just 1 minus x. P of x is just equal to x. Our left-hand limit, a, is equal to 0, and our right-hand limit is equal to 1. Those are our x values. So we have all that, and now all we have to do is write the equation for volume. Volume of a solid rotated around a vertical axis is 2 pi, the integral from a to b of p of x times h of x times dx. So we just have to stick everything in that we already had specified. So we go from 0 to 1. P of x is x. H of x is 1 minus x. And we multiply the whole thing times dx. So we multiply out. So x times 1 is x. X times negative x is negative x squared. We integrate. The integral of x is x squared over 2. The integral of x squared is x cubed over 3. We've integrated, so we remove the integral sign. We draw our straight line, and we integrate from 0 to 1. And then we plug in the two limits. So we have 2 pi times the functions evaluated the upper limit minus the functions evaluated the lower limit, which in this case is 0. So this just goes to 0. And 1 cubed and 1 squared is 1, so you get 2 pi times 1/2 minus 1/3. So our common denominator is 6, so we'll end up with 2 pi. 1/2 is 3/6. 1/3 is 2/6. 3 minus 2 is 1, so we get 2 pi times 1/6. 2/6 is the same as 1/3, so the area is going to be pi over 3. I mean the volume, sorry. The volume is pi over 3, so I'm just checking the answer in the solution manual. Make sure I did it all correct. Pretty sure I did. pi over 3. Okay, so that's correct. Okay, this is problem number 4, and I've drawn the area in Illuminate, in using the graphing program, but you can see it in your text. So what we have is we have a horizontal line here at y equals 8, and we have the x-axis. And so we're creating a rectangle. We're building upon having a rectangle in this direction, which is going to be using the shell method because we're rotating around the y-axis. And the equation, so this is problem number 4, and the equation that we're given is that y equals x squared plus 4. So based on the orientation of the rectangle, we're actually going to be integrating with respect to x, because we move this rectangle back and forth in that direction. So that tells us sort of what this thing is set up to be like. So because of that, our volume using the shell method, and again it's going to be the shell because this rectangle is going to rotate around there and create a shell or a cylinder. And for that case, we have the integral 2 pi times the integral from a to b of p of x, because we're integrating with respect to x, times h of x times dx. Since we are rotating around the y-axis, our p of x is just going to be, which is our radius to the shell, out to the center of the shell, is just going to be equal to x. So p of x equals x. H of x is the height of this element. The height is going to be the total distance from the top to the x-axis, subtracting off the distance from the x-axis to the curve. So h of x is just 4, or pardon me, is 8, minus the function, which is going to be x squared plus 4. And we can rewrite that. It's just going to be equal to 4 minus x squared. So that's the height of the rectangle as a function of x. At x equals 0, it's 4. At x equals 2, it's going to be 0. So it goes from height of 4 to height of 0, and it follows this relationship. So the volume is 2 pi times the integral from, what are the limits? We go from x equals 0 to x equals 2. That's 2. So we go from 0 to 2. We have p of x, which is x, times h of x, which is 4 minus x squared, all times dx. Before we integrate, we multiply out terms, so we just have individual polynomial expressions, instead of trying to use the chain rule or something like that, which we could do, but it's easier just to multiply it out. So we get 4x minus x cubed, everything times dx. So now we integrate. I'll leave the volume off for a second. So we get 2 pi times 4 times x, integral of x, which is x squared over 2. We subtract off x to the 4th over 4. And when we evaluate that integral between x equals 0 and x equals 2. So we have 2 pi times 4 times 2 squared divided by 2 minus 2 to the 4th over 4. That's the upper limit. And we subtract the lower limit, which is going to be 0 minus 0, which is 0. So multiplying everything out inside, we have 4 times 4 is 16 divided by 2 is 8. And here we have 2 times 2 times 2 times 2, which is 16, divided by 4, which is 4. So we'll have 4 times 2, which is 8, and so we get 8 pi. And that is the volume of that shape rotated around the y-axis. Okay, this is problem number 4. And I've drawn the area in Illuminate, in using the graphing program, but you can see it in your text. So what we have is we have a horizontal line here at y equals 8, and we have the x-axis. And so we're creating a rectangle. We're building upon having a rectangle in this direction, which is going to be using the shell method because we're rotating around the y-axis. And the equation, so this is problem number 4, and the equation that we're given is that y equals x squared plus 4. So based on the orientation of the rectangle, we're actually going to be integrating with respect to x, because we move this rectangle back and forth in that direction. So that tells us sort of what this thing is set up to be like. So because of that, our volume using the shell method, and again it's going to be the shell because this rectangle is going to rotate around there and create a shell or a cylinder. And for that case, we have the integral 2 pi times the integral from a to b of p of x, because we're integrating with respect to x, times h of x times dx. Since we are rotating around the y-axis, our p of x is just going to be, which is our radius to the shell, out to the center of the shell, is just going to be equal to x. So p of x equals x. H of x is the height of this element. The height is going to be the total distance from the top to the x-axis, subtracting off the distance from the x-axis to the curve. So h of x is just 4, or pardon me, is 8, minus the function, which is going to be x squared plus 4. And we can rewrite that. It's just going to be equal to 4 minus x squared. So that's the height of the rectangle as a function of x. At x equals 0, it's 4. At x equals 2, it's going to be 0. So it goes from height of 4 to height of 0, and it follows this relationship. So the volume is 2 pi times the integral from, what are the limits? We go from x equals 0 to x equals 2. That's 2. So we go from 0 to 2. We have p of x, which is x, times h of x, which is 4 minus x squared, all times dx. Before we integrate, we multiply out terms, so we just have individual polynomial expressions, instead of trying to use the chain rule or something like that, which we could do, but it's easier just to multiply it out. So we get 4x minus x cubed, everything times dx. So now we integrate. I'll leave the volume off for a second. So we get 2 pi times 4 times x, integral of x, which is x squared over 2. We subtract off x to the 4th over 4. And when we evaluate that integral between x equals 0 and x equals 2. So we have 2 pi times 4 times 2 squared divided by 2 minus 2 to the 4th over 4. That's the upper limit. And we subtract the lower limit, which is going to be 0 minus 0, which is 0. So multiplying everything out inside, we have 4 times 4 is 16 divided by 2 is 8. And here we have 2 times 2 times 2 times 2, which is 16, divided by 4, which is 4. So we'll have 4 times 2, which is 8, and so we get 8 pi. And that is the volume of that shape rotated around the y-axis. This is problem 10 on Chapter 7, Section 3. So we have this given information. We have a curve y equals 2x. We have a curve that y equals 4 and that x equals 0. So we're going to go ahead and plot that. So let's go and find the graphing program. So this is pretty straightforward. It's just a straight line going through the origin, and it looks like that. So let's get my camera and let's take a picture. And we'll go back to Smartboard. Okay, so there's our graph. And we have a line which is y equals 0. Pardon me, y equals 4. So y equals 4 is this horizontal line. And we have x equals 0. So it's that. So that's pretty well-defined triangle. And we're rotating around the y-axis. So we're going around this axis. And because we're using the shell method, we would draw the rectangle in this direction. So when we rotate this rectangle around the y-axis, we create a little shell, a little cylinder. And our axis of rotation, our radius is that. And we know, therefore, that P of x is equal to x. We're integrating with respect to x, and therefore our limits of integration are going to be 0, and this value of x, which is 2. So our expression for the volume of revolution around the y-axis, a vertical axis, is 2 pi times the integral from a to b, we're going in the x direction, of P of x times h of x times dx. So we just said P of x is just x. That's the line from the y-axis to the center of the rectangle. So that's x. In terms of h of x is the height of the rectangle. So if we go over here, the height, one side is y equals 4, and the bottom is y equals 2x. So this distance, let's put an arrow here. This distance is y equals 2x, the bottom part, and the top part is y equals, so the outside radius not really the outside radius, but the curve that defines the other side of the expression is y equals 4. So h of x is going to be 4 minus 2x. So we can substitute that in. Volume equals 2 pi. We integrate from x equals 0 to x equals 2. This is x equals 2. P of x is x. H of x is 4 minus 2x dx. We multiply out this term, 4x minus 2x squared, the whole thing times dx. And now we can actually do the integration, simple polynomial integration. 4 times the integral of x, which is x squared over 2, minus 2 times x squared, the integral of x squared, which is x cubed over 3. And then we evaluate the integral from x equals 0 to x equals 2. So we have 2 pi times 4 times the upper limit squared, which is 2. We have the second term, which we also evaluated, the upper limit. So that's the upper limit. The lower limit is 0 because it's polynomial. Again, don't be fooled. If you have something that's other than a polynomial, then it's not necessarily equal to 0. So now we're going to multiply everything out. So let's think about this. We have 4 divided by 2 is 2. 2 times 2 times 2 is 8. Here we have 2 times 2. So we got 2 times 2 times 2 times 2. 2 to the 4th, it's 16. So we have 16 thirds. So we find the common denominator of 3. So we multiply 8 by 3 to get 24. So then we have 24 minus 16, which is 8. And finally, we'll multiply out. So we have 16 pi over 3. So I've checked the answer manual, and that is correct. So that's the correct answer. So just kind of in review, what we did was we plotted the value, the line y equals 2x, which is this slanted red line. We plotted y equals 4, x equals 0, which defined this area. We were told in the problem that we were rotating around the y-axis, and we're using the shell method. So we draw a rectangle such that when it's rotated around the y-axis, creates a shell. Because this rectangle is vertical, we're going to move this horizontally to fill out the entire area, to cover the entire area. It'll be this long on the left-hand side, and it'll shrink down to 0 on the right-hand side. So anytime you're rotating around the axes, it's just the distance from the axes to the rectangle, which is x. So p of x was x. The height of the rectangle is h of x. So the height is going to be this distance, which is 4, subtracting this distance, which is 2 minus x. And so this distance is going to be 4 minus 2x. Okay, so that's h of x. So then if we go back over to the other page here, the volume of a surface of revolution rotated around, using the shell method, around a vertical axis is 2 pi, the interval from a to b. These are x limits. P of x, h of x dx. P of x is x. H of x is 4 minus 2x. Plug that in, multiply it out, do the integrations, evaluate the function, the upper limit, subtract the function, evaluate the lower limit, multiply it out. If you got fractions, find a common denominator, combine the terms into one denominator, into one fraction, and then simplify as far as you can go. Look for common terms that you can divide out. Okay, this is problem number 1473 in calculus. And we looked at this problem in class. Let me just do a sketch of it. This was the one that was a little strange because it was underneath the axis, which we're not used to seeing. So since this is in your book, I won't spend a huge amount of time getting the drawing perfect. But it asks for the volume as you rotate this around the x-axis using the shell method. So we need to put a rectangle in here. And because of the shell method, it's going to be parallel to the axis of rotation. And so since we're using the shell method and we're integrating, we're going around a horizontal axis of rotation, the volume is equal to 2 pi integral from c to d of p of y, h of y, dy. It's y because this rectangle would move up and down to fill out the entire area. So we have P of y, which is this radius, and we use negative y in this case. So P of y is negative y. If it was above the x-axis, it would be positive y, but this is negative y. And the height of this is x equals 4, and because we're integrating with respect to y, we have to take the original equation, which was given in terms of x. So we have y is equal to 2 minus x. So if we solve for x, we would get, if we add x to both sides and subtract y from both sides, we get x is equal to 2 minus y. And if this makes sense, when y equals 0, which is right here, x will equal 2. And when x equals 0, y is equal to 2, so that it matches out. So the height is this distance. And since the whole distance from the y-axis, since we're doing this, this is y. I mean, pardon me. This is x. Make sure I'm doing this right here. So this is x equals 4. Okay, so it is a function of, it's a function of y, but y is equal to 0 in this case. So it's just x equals 4, just like we have x is equal to 2 minus y. So this distance here is equal to 2 minus y. That's the function, that's the curve. So this distance here is going to be 4 minus 2 minus y, which is the same as 2 plus y. So that's what h of x is. H of x, pardon me, h of y is equal to 2 plus y. Okay, so now we can just plug it in. Our y limits of integration are from 0 to y equals negative 2. Okay, so this is negative 2 right here. This is 0. So we integrate from 0 to negative 2. So now we can plug in and plug and chug. 2 pi, the integral from 0 to negative 2, P of y is equal to negative y. And h of y is 2 plus y multiplied by dy. And so we get 2 pi times the integral from 0 to negative 2 of negative 2y minus y squared, the whole thing times dy. And actually we should be integrating the other direction. It's so hard when it's the other way around. You kind of get used to it. So we should be integrating so it's more positive. So it goes from negative 2 to 0. Negative 2 to 0, because we're going from the lower y value to the upper y value, just like we would start with the lower y value to the upper y value. So it's going to be from negative 2 to 0. So when you integrate negative 2y, you get negative 2y squared over 2. The integral of y squared is y cubed over 3. And we evaluate that between y equals negative 2 and y equals 0. So the upper limit is going to make this thing go to 0. And the lower limit, so we're going to actually subtract the lower limit. So these will become pluses when we subtract it. So we will get, and these 2's cancel out, so let's go ahead and do that. So we'll have plus negative 2 squared plus negative 2 cubed over 3. So negative 2 squared is 4. Negative 2 cubed is negative 8. So we'll get negative 8 thirds. And if we convert this to thirds, that's 12 thirds, because we multiply both the numerator and the denominator by 3, minus 8 thirds is equals 2 pi times 4 thirds. And so the final answer is going to be 8 pi divided by 3. And if we got a negative number, we would have realized we've done something wrong relative to the limits, or p of x. This is problem number 15. We're going to use the shell method to calculate the area represented by this curve, the two vertical lines, and the x-axis. And because the function changes from here to here as far as the upper boundary, the more positive y boundary, then it means we have to do two integrals. So we're going to do one from here to here. And because these are moved vertically, it's going to be an integration with respect to y. So let's just go ahead and write the equation down. The volume is equal to 2 pi times the integral from c to d of p of y, h of y times dy. Okay, so p of y is going to be equal to y. So that's it for that one, and that's for it for the higher one, but it's still just going to be y, the y coordinate, and it's because we're rotating around the x-axis. Now, as far as the height is concerned, the height's going to be the same all the way through this particular area. So we're going to break it up into two integrals, one from 0 to pi, one from 0 to half, and one from a half to 1. And I'm trying to think if there's anything else we need to do. The equation is y is a function of x. We need to do x as a function of y, which is the same equation. It's just instead of y equals 1 over x, it's x equals 1 over y. So now I have this curve. So we just break it up into two parts. So it's equal to 2 pi times the integral from 0 to a half. P of y is y. H of y is just 2 minus 1, which is just 1 times dy. And then we do the second area, which is going to be 2 pi times the integral from 1/2 to 1 of p of y, which is still y. And the height is going to be the upper curve, which is going to be 1 over y. So we're using this version, 1 over y. And we're going to subtract this distance, which is 1. And the whole thing is going to be multiplied by dy. I forgot a negative sign there. -1. Let me just erase that and fix that. Okay, so that's the equation. Let's put two screens up, and we'll just do the integration. We'll have to multiply this out, so let's go ahead and use this. Let's use this old screen. 2 pi, the integral from 1 to 1/2 of y dy, plus 2 pi, the integral from 1/2 to 1 of y times 1 over y is 1, and y times -1 is -y. Okay, so now we integrate it. We get 2 pi, the integral of y dy is y squared over 2. We integrate that between 0 and a half. And then we do the second integral. The integral of y dy is just y. So we get y minus y squared over 2 for the second part. And we evaluate that between 1/2 and 1. I'm going to factor out the 2 pi, so just do that one time. So we'll get 1/2 squared divided by 2 minus 0 squared divided by 2. And let me put a bracket around the outside. So this is this term. And then we have, I factored the 2 pi out, so that's already out there. So we'll have, I'll just do the y part first. So we have 1 minus 1/2. So this is y at the upper limit minus y at the lower limit. And then we have minus y squared, so we'll have 1 squared over 2 minus 1/2 squared over 2. And that whole thing is closed. So we get 2 pi. This will be 1/4 divided by 1/2, or divided by 2 is 1/8. And then we'll have plus 1/2. And from this part, we will have negative 1/2. And then we'll have 1/2 squared, which is, we have negative 8. 1/2 squared is 1/4, divided by 2 is 1/8. So I'll have negative 1/8. And we close the parentheses. Well, you see this half cancels out with that half. This becomes positive 1/8. So we'll end up with 2/8 inside. And so that just ends up being pi over 2. Okay, but this is problem number 24. So if we plot the functions, so what we have, let's just write down what we have first. Y equals the square root of x. Y equals 0. X equals 4. About the line x equals 6. So x equals 6 is going to be a vertical line. So we're going to have a vertical axis rotation. Okay, let's draw our picture. So the square root of x is always positive. So it starts here at 0 and then it goes like that. So this is y, this is x. Okay, so that's that function. This is y equals the square root of x. We have y equals 0, which is the x-axis, and we have x equals 4. So you can see this is the area that's defined, and we're going to rotate that around the line x equals 6. So here's x equals 6. So we're going to rotate around that line. So let's go ahead and put our rectangle in here. So our radius is going to be the distance from x equals 6 to here. And the distance from here to here is x. So notice we are integrating with respect to x. And so this distance here is x. This whole distance here is 6. And therefore, p of x is 6 minus x. H of x is this side minus that side. Well, this side is 0. So h of x is just equal to the square root of x. Our limits are going to be 0 right here at this corner, and x equals 4. So we go from 0 to 4. Those are our limits of integration. So we know that a equals 0, which is our lower limit, b equals 4, which is the upper limit. So this is x equals 0, one limit, x equals 4, which is the upper limit. So that's a, that's b. Okay, so the volume using the shell method, where you have a vertical axis of rotation, is 2 pi integral from a to b of p of x times h of x times dx. So a is 0, b is 4, p of x is 6 minus x. H of x is the square root of x. multiplied by dx. So that's our formulation. So we're going to multiply this out before we integrate. So we'll get 6 square root of x minus 6. Okay, what do we have here? X to the first, x to the half, so you add the exponents. So you'll have x to the 3/2. And really, I'm going to change the square root to a fractional exponent. Let's bring the 6 out, so I don't have to worry about that. So 6 times 2 is 12, so that'll come out. And I'm going to, before I integrate them, still one more step, and that's to change x, square root of x to x to the 1/2. Okay, now we integrate. And even though it's not an integer exponent, it's still a power. So we get x to the 3/2 divided by 3/2, and then we subtract x to the 5/2 divided by 5/2. And we evaluate that between 0 and 4. So I'm adding 1 to this. 1/2 plus 1 is 3/2. 3/2 plus 1 is 5/2. And before we actually plug it in, let's do the reciprocal. So you get 12 pi 2/3 x to the 3/2 minus 2/5 x to the 5/2. Evaluated between 0 and 4. And again, anytime it's an exponent, a power, when you put 0 in, you're going to get 0. So the second part will be 0. The first part, we have 4 to the 3/2 power minus 2/3, 4 to the 3/2 minus 5/2 times 4 to the 5/2 minus 0 from this part. So what we can do is take the square root and then cube it. So this is the same as the square root of 4, the whole thing cubed. And this one would be the 5th. So the square root of 4 is 2. 2 cubed is 8. So we'll get 2 times 3 times 8. And here we'll get 2 divided by 5 times 2 to the 5th power, which is 32. And I'm having a little concern because my first feeling is that's going to be greater than, it's going to be give me a negative result. So why is that? Well, I guess I have to make sure it really is true, but it just seems like it is. The reason I say that is this is 4 times that. This is not 4 times that. Therefore, it's going to be negative. So let me think about that. Let's just go back here. Let's see if we can figure out where we went, if I went wrong somewhere. Okay, well, you may have already noticed it, and I just didn't see it. So this is not 6. So what we have to do is we have to correct these little bits there. So let's take that out of there. Make that 2 pi instead of 12 pi. So this still has a 6 in front of it. Can't do that. So one thing again out of this again is sometimes you have to kind of think about when you get to the end and you get an answer that doesn't make any sense, then it's time to regroup and figure out what the heck is going on here. So I'm just going to erase all this stuff. Okay, make sure I got it all right. Okay, now we can do it. So we get 2 pi, not 12 pi. 6 times x to the 1/2. Actually, we have to integrate. So let's, and I need to go back here and make this to the 1/2 power. Okay, 6 times x to the 3/2 divided by 3/2 minus x to the 5 halves divided by 5 halves. Okay, now we evaluate it between 0 and 4. Okay, so we have 6 times 2/3 x to the 3 halves minus 2/5 x to the 5 halves between 0 and 4. This becomes 2, so we get 2 times 2, which is 4. So we'll get 2 pi times 4 times x, which is 4 to the 3 halves minus 2/5 times 4 to the 5 halves minus 2 pi times 0. So what we'll have is 2 pi times 4. This is going to be square root of 4 is 2. 2 cubed is 8. So this becomes 32. And here we get 2 times square root of 4 is 2. 2 to the 5th power is 32. So we get 32 over 5. And 2 pi, okay, let's put it in fifths. So 5 times 32 is 160, so it's 160 fifths minus 64 fifths. 160 minus 64 is 96 fifths. 96 times 2 is 192. 192 pi over 5. And let's check the answer here. 192 pi over 5. So that's its correct answer. Okay, this is problem number 19, section 3, chapter 7. And it says we have the following functions, or the following curves: x plus y equals 4, y equals x, and y equals 0. So I've got two curves plotted. I've got y equals x, which is the blue line, and I have x plus y equals 4. We can rewrite that y is equal to 4 minus x. That has a negative slope, intersects the y-axis at y equals 4. So that's two sides. And we have the third side, which is y equals 0. So we have this triangle. And they're asking us to rotate this around the x-axis, so we draw a rectangle. Since we're using the shell method, we're going to draw it parallel to the axis, the axis of rotation, which is the x-axis. So I'm going to put my arrow there. So what we have is we're going to integrate with respect to y, because this goes up and down. The values of y vary between 0, which is this surface, and where they intersect, which is 2. So our limits of integration from 0 to 2. The radius that goes from the axis of rotation to the rectangle is just going to be equal to y. And the height of this is this function minus that function. We have to do it as a function of y. So what we'll have is we need to solve both of these equations. X is a function of y. So let's write it down here at the bottom. So x is equal to 4 minus y is one curve, and the other curve is x is equal to y. This is that curve, and this is that curve, so we're going to subtract this from that. So let's put two pictures up here. So what we have is r of y, or p of y, which is the radius to the shell. P of y is y, because we're rotating around the x-axis. H of y is going to be this curve, the red curve, which is y. Pardon me, it's 4 minus y. So we have 4 minus y, and we subtract the lower curve off, which is y. So what we'll end up with 4 minus 2y. And so we can calculate the volume now. The volume using the shell method around a horizontal axis is going to be equal to 2 pi. We are integrating in the y direction, so we use the y limits, which are from 0 to 2. P of y is y. H of y is 4 minus 2y. And we multiply by dy. So we multiply out what's in here. We'll end up with 4y minus 2y squared, the whole thing times dy. We integrate. So we'll get 4 times y squared over 2 minus 2 times y cubed over 3. And then we'll evaluate that between y equals 0 and y equals 2. So plugging in, well, let's first replace this. 4 divided by 2 is 2. The lower limit, everything's going to go to 0, so we just evaluate at the upper limit. So it's just going to be 2 times 2 squared minus 2 times 2 cubed over 3. So finally, maybe not finally, we might have one more step. We have 8 minus, we've got 2 cubed is 8 times 2 is 16 thirds. Find a common denominator, which is going to be 3, so we multiply 8 by 3 to get 24 thirds minus 16 thirds. And so we have 2 times 8 thirds. 24 minus 16 is 8. So we finally end up with 16 pi divided by 3. This is problem 21 in section 3. We're given 2 functions, and the blue function here is 4x minus x squared. The red function is y equals x squared. So this is y, and this is y. And it says we rotate this area, which is the area inside here, around the line x equals 4. So we're going to draw a vertical line here at x equals 4. So this is the one that we rotate around. And because we're using the shell method, we're going to make our rectangle to be parallel with the axis of rotation. So this is going to be our rectangle. So when this rotates around this, it'll go out into the screen and back into the screen, away from the screen. So it'll create a shell. And it's going to have a radius. So P of x is the radius. And it's a function of x because we're going to move this back and forth in the x direction. And then we have h of x, which is the height of the rectangle. So this is h of x. And h of x is going to be this function, the blue curve minus the red curve. That'll give the distance between the two curves. Our limits of integration are going to be from x equals 0 to where this intersects, which is x equals 2. So let's put up another screen and write everything down that we know. Okay, we're using the shell method. And we're rotating around the line x equals 4, which is this vertical red line. P of x is not going to be x in this case. It's going to be 4 minus x. This is x equals 4 is the vertical line. And so this distance is 4. This is x, so this is going to be 4 minus x. H of x is the upper curve, which is the blue curve, which is this. So we have 4x minus x squared. And then we subtract off the lower curve, which is y equals x squared. So we get 4x minus 2x squared, because we'll have negative x squared gives us negative 2x squared. So our volume, using the shell method, and we integrate with respect to x, again, because this moves back and forth this way. We integrate from 0 to 2 of p of x, which is 4 minus x, times h of x, which is 4x minus 2x squared, the whole thing times dx. So we multiply this out, and we'll get 16x, 4 times 4, x is 16x. We'll get negative 4x squared by doing the inner. The outer is going to be negative 8x squared. And finally, when we multiply it last, we'll get positive 2x cubed, all times dx. Let me look for if there's any common terms that we can combine, which there are. So we'll get 16x minus negative 4 minus 8 is negative 12x squared, plus 2x cubed, all times dx. And so we integrate now. And did I do something wrong? No, oh, okay. So we integrate, and what we will get is 16 times x squared over 2 minus 12 times x cubed over 3 plus 2 times x to the 4th over 4. And we evaluate that between x equals 0 and x equals 2. So all we have to do is evaluate the upper limit, because the lower limit, being a polynomial, as usual, that goes to 0. So we'll end up with 2 pi times 16 times 2 squared over 2 minus 12 times 2 cubed over 3 plus 4 times 2 to the 4th over, oops, I got an extra 2 in there. How did they do that? So we have 2 times 2 to the 4th over 4. So that's the upper limit, and the lower limit is 0. So here we'll have 2 squared divided by 2, which would be 2, times 16 is 32. We have 2 cubed, which is 8, times 12 is 96. So we'll get 96 over 3. And here we'll have 2 squared cancels out with 4, so we'll have just 2 squared times 2, so that will be 8. Let's combine the two whole numbers. 40 minus 96 over 3. And we find the common denominator, which we have as 3. So we'll have 120. 40 times 3 is 120. Divided by 3 minus 96 divided by 3. And so that's going to be 24. So we'll have 2 pi times 24 over 3. 24 over 3 is 8. So we'll have 8 times 2, which is 16, and we get 16 pi. So that's the volume that we get. And that is the correct answer. Okay, this is problem 27, section 3, chapter 7. So we're asked to use either the disk or the shell method to find the volume of the solid generated by revolving the region bounded by the graphs of the equations about each given line. So there's 3 choices, A, B, and C. Actually not choices, but 3 parts. And the area that we're talking about is y equals x cubed, which is the red curve that you see right now. And you have y equals 0, which is a horizontal line. And you have x equals 2, which would be a vertical line here at x equals 2. So you can see the area. It's right here. So in some ways we could probably use either the disk or the shell method in this case, because the upper part of the curve is consistent, the lower part of the curve is consistent. So the only difference is that if we just leave it as y equals x cubed, therefore integrating with respect to x, then the integrations are simpler than doing it the other way where you'd have y to the 1/3 power or something like that. So we're going to integrate with respect to x. We're going to use the disk method if we rotate around the x-axis, and we'll use the shell method if we rotate around the vertical axis. And we have three choices. We have A is around the x-axis will be the disk method. Around the y-axis, which is part B, will be the shell. And then we also have y equals 4, which is also going to be a shell, but it's going to have, we're going to rotate around this area instead. So let's do part A, which is rotating around the x-axis. So this is the disk method. So rotate around the x-axis. And our function that bounds the outside of this rectangle is x cubed, y equals x cubed. The inside is the x-axis. So the volume in this case, since we have a horizontal axis of rotation, the volume is going to be pi times the integral from a to b of capital R of x, quantity squared dx. In this case, R of x is equal to x cubed. And the limits of integration are the x limits, which go from 0 to 2. So our integral for the volume is going to be equal to pi times the integral from 0 to 2 of x cubed quantity squared dx. Multiply things out inside the integral sign, so we get x to the 6th dx. When we integrate that, we get x to the 7th over 7. We evaluate that between x equals 0 and x equals 2. The lower limit, because it's a polynomial, it goes to 0, and then we have 2 to the 7th power, which 2 to the 7th power is, that's wrong direction here. 2 to the 7th power, not 7 to the 2nd, that was 128. So we get 128 pi divided by 7 is the volume. Okay, so that's the first part. The second part is around the y-axis. In that case, we're going to have the shell method. The radius is going to be equal to x because we're rotating around the x-axis. So part B, this is where we rotate around the y-axis. And we're going to have a shell. And the volume, using the shell method, around a vertical axis of rotation is from the integral from 2 pi times the integral from a to b of p of x times h of x dx. P of x is equal to x. H of x is just the height of the rectangle. Let's go back. Which is just this height, which is just the function x cubed minus 0, which is the x-axis. So h of x is going to be x cubed. So we can plug in the volume is equal to 2 pi, the integral from 0 to 2, same integration limits, x times x cubed times dx. So we get 2 pi, the integral from 0 to 2 of x to the 4th dx. Integrating x to the 4th, we get x to the 5th over 5 integrate between x equals 0 and x equals 2. Again, the lower limit goes to 0, so we're going to have x to the 5th, which is 2 to the 5th. So let me just put that in there this time. I forgot last time. So we got 2 to the 5th over 5 minus 0, the lower limit. 2 to the 5th is, I think, 32. So we have 32 times 2 divided by, well, 32 times 2 is 64. So we have 64 pi divided by 5. And then the final one is really just the same as what we just did here, except p of x, instead of being x, so part C, rotating around the line x equals 4. If we go back to the original drawing, r is this distance. So this whole distance is 4. This distance is x cubed. So this is going to be, this distance here will be 4 minus x cubed. Actually 4 minus x, sorry. So ignore what I just said. The distance was x to the curve. The total distance was 4. And therefore p of x is 4 minus x. H of x is the same thing. It's the height of the rectangle. So the volume is equal to 2 pi, the integral from 0 to 2 of 4 minus x times x cubed times dx. P of x, h of x, dx. So we multiply this out on 4x cubed minus x to the 4th, that whole thing times dx. So we integrate, and we'll end up with 4x to the 4th over 4 minus x to the 5th over 5, evaluated between x equals 0 and x equals 2. So we have 2 pi times, these cancel out, so we'll have 2 to the 4th minus 2 to the 5th over 5. So 2 to the 4th is 16, 2 to the 5th is 32. To find the common denominator 5, we'll multiply this by 5, which will give us 80, 80 fifths. Minus 32 fifths, and that's 48 fifths, times 2 is 96. So we'll get 96 pi over 5. Okay, we're going to do problem 28. These are the equations and lines that define the boundary. So I put in one of them, which is the curve. I'm going to put in the other boundary. So we have y equals 0, we have x equals 1, and we have x equals 5. And we can use either the disk or the shell method depending upon what we want to do. And really what we do is we choose a rectangle that is appropriate for this setup. And we've talked about this in class numerous times. So we would use a vertical rectangle because a horizontal rectangle would result in a change in the function from one function to another. So whether we use the shell or this method, it all depends upon which axis we're rotating around. So all of the integrations are going to be with respect to x because this always moves back and forth left to right. If we go around the y-axis, we'll use the shell method. If we go around the x-axis, we'll use the disk method. So the first case is for the x-axis. So if we rotate around the x-axis, it's going to be a disk. And we only have r of x. We just have the outside radius, which is 10 over x squared. Our limits are going to be from x equals 1 to x equals 5. So the volume using the disk method is pi times the integral from a to b. In this case, a is 1, b is 5, of r of x, quantity squared, dx. So we integrate that, but we first need to multiply it up. We always do that. So we have pi, the integral from 1 to 5 of 100 divided by x to the 4th dx. And remember that is the same as 100 times x to the minus 4 power dx. Whether you do that in your mind or whether you do it actually, you always have to do that. You don't do the integral when it's in the denominator. Okay, so we integrate pi times 100, and the integral of this is going to be x. So we're integrating, so we add 1 to the exponent and divide by the new exponent. And we integrate between x equals 1 and x equals 5. So it's one of these cases where the lower limit is not 0. Therefore, we can't just kind of ignore it. So we have 100 pi times, and let's take the 3 out. And so we're going to have a negative, and we have 1 over x cubed. So this is the same as x to the minus 3 power is 1 over x cubed. In this case, the upper limit is 5, so we have 5 cubed, and then we have minus the lower limit, which would make it a plus sign, 1 over 1 cubed. So what do we get? So 5 cubed is going to be, so the volume is equal to 100 pi divided by 3 times negative 1 over 125 plus 1. And so what we get, we would get 124 over 125. So as far as simplifying that, just checking out the book here, make sure I get all this right. I almost looked at the wrong problem. Okay, so everything's right. So we're able to simplify a few things here. Let's see, we have 25. So this would become 4, and this would become 5 if we divide by 25 in both the numerator and the denominator. So then, let's see, is there anything else that we can simplify? I think that's pretty much it. So 4 times 124. 4 times 124 is 496. So we get 496 pi divided by 15. And that's the answer. So that's about the x-axis. Okay, so we'll go to the next part. The next part is around the y-axis. So in this case, let's go back to the original drawing. If we rotate around the y-axis, we're going to have a shell. And p of x is going to be x. It's going to be this distance here. H of x is just going to be 10 over x squared minus 0. And we're integrating with respect to x, so we integrate from 1 to 5. So what we're going to end up with, for a shell rotated around a vertical axis, is 2 pi, the integral from 1 to 5 of p of x, which in this case is x, times h of x, which is 10 over x squared, all times dx. So this one's a lot easier. So we're going to multiply out inside the integral sign. So we'll just have 10 over x dx. We integrate. So let's go ahead and take the 10 out. So we have 20 pi times the integral of 1 over x is the natural log of x. and we evaluate that between x equals 1 and x equals 5. So we have 20 pi times the natural log of 5 minus the natural log of 1. Natural log of 1 is 0, so we'll end up with the final answer being 20 pi times the natural log of 5. Okay, so that's part B. And then part C is we rotate around the line y equals 10. So if we go back here, if we put a line y equals 10 in here, so we got that. So it's going to be like we're rotating around the x-axis, but it's been shifted up. So now it's going to be the washer method. And let's go ahead and draw in some arrows here. So what we have is we have small r of x, which is the inside radius, and we have large r of x, which is the outside radius, which is constant throughout the thing. It's going to be 10. Okay, so this is small r of x, large r of x. So for a washer method problem, so we're going to say this is around y equals 10. It's the washer method. And so we said r of x, that's the inside radius, is going to be equal to 10 minus 10 over x squared. Okay, we've done that many times before. So that's the outside, that's the total distance we subtract off to the bottom of the curve, and the difference is that big R of x is 10. So the volume using the washer method is pi, the integral from 1 to 5. So we have large R of x squared minus small r of x, whole thing squared, all times dx. So remember, this is big R of x, little r of x. We square them, we subtract them off. So all we have to do is multiply stuff out. So we'll get 100 from 10 squared. Then when we do this second part, we'll end up with 10 squared, which is 100. 10 times 10 is 100. We have a negative sign, so it's going to be negative 100, and we have that twice. So we'll have negative 200 over x squared, and then the last terms multiplied together will give us positive 100 over x to the 4th. That all times dx. And you can see the hundreds cancel out, and so what we're left with is negative 200 over x squared plus 100 over x to the 4th, the whole thing times dx. And now we'll integrate. So when we integrate this will be x to the minus 2 power. So when we integrate, we'll get x to the minus 1 divided by negative 1. The second part, we'll have 100 times x to the minus 3 power over negative 3, because we're adding 1 to the exponents. And we'll evaluate that between x equals 1 and x equals 5. So that's the same as 200 over x. I have a negative sign. Actually, we had a negative sign there, so the two negative signs will become a positive sign. This one will be negative, and we'll have 100 over x cubed. Okay, now we plug the numbers in. And I'm going to do it where we're going to do 200 times 1 over 5 minus 1 over 1. That's the first term evaluated. The upper minus the lower. Then we have 100 times 1 over 5 cubed minus 1 over 1 cubed. The whole thing closed. Okay, so here we'll have 1/5 minus 1 5/5, so we'll have negative 4/5. So we'll have negative 4/5 times 200, which would be negative 800 fifths. This part we're going to have negative 100 times. So we've got, this is 125, so we end up with minus 1. We'll end up with minus 124 over 125, just like we did earlier. And I think we're going to be able to make that into a, if we divide by 5, we'll have 20 here, and we'll have 25 there. And if I do a common denominator of 25, I'll have negative, to get 25 I'll have to multiply by 5, so I'll have 4,000 over 25. And here I will have, so over 25, so 20 times 124, and it'll become positive, so 20 times 124, I get 2,480 over 25, which is negative, which is bothering me. So I'm not sure what the issue is right now. I'm just going to look at the solution here to see if I can see anything that looks suspicious. I forgot a 3 here. Okay, so when I integrate this, it's going to be, I divide by negative 3. So I guess, yeah, we go back up here. I forgot the negative 3. Okay, so there's a 3 right here. And so there's a 3 right there. And so there'll be another 3 right there, which actually will go okay, now I found one other sign error. So there was actually a negative sign here. So we're going to have a negative sign. We'll carry this right through. Okay. So we'll have a 3 right there. And so let's see what we get now. We'll get, and we'll have to multiply that by 3 to get a common denominator. So we've got negative pi times 4,000. So that'll be 12,000 divided by 75 minus, this will be minus, this will be plus. And so we'll get 2480 divided by 75. So 12,000 minus 2480 is 95. And this negative, this is going to be negative. So we'll have, let me just put that in there, negative 9,520 divided by 75. And so then we end up with positive pi, negative times a negative positive, 9520 divided by 75. And it turns out there's a common denominator here. We can divide by 5. So if we divide both the numerator and the denominator by 5, we get 1904 pi over 15, which is the correct answer. Okay, 33. It says, give a geometric argument explains why the integrals have equal values. So we have two integrals. We have pi times the integral from 1 to 5 of x minus 1 dx. And they're saying that's equal to 2 pi times the integral from 0 to 2 of y times 5 minus y squared plus 1 dy. So both of these represent volumes, and what we can do is if we can show what this represents, and then this one's going to be using something like the disk method, and this one's going to be using the shell method. So let's see if we can figure out what that means in terms of areas. Or what does this geometrically mean? So if we draw a line x minus 1, that's going to have a slope of 1, and it's going to intersect the x-axis. So it's going to look something like that. And it says, and so this has a y-intercept of -1. That's from the, if we took y equals x minus 1, that's this curve, y equals x minus 1. Okay, now, well actually, what that is if this were using the disk method, that would actually be, this would be r of x squared. So actually that's not correct. Let's fix that. Okay, so what this is saying, if this were pi times the integral from a to b of r of x squared dx, that would mean that r of x is equal to the square root of that quantity, or y is equal to the square root of x minus 1. So this is a square root function. It hasn't when x is equal to 1, y is equal to 0, and then it goes like this. If we had y equals negative, it would look something like that. Okay, so this would be y equals the square root of x minus 1. This would be y equals negative the square root of x minus 1. And then it's saying, so that's that would be the outside radius, and it's saying we integrate from 1, so this is x equals 1 to 5. So here's 5. So we draw a vertical line at 5. This is the x-axis. So our area, this expression here is equivalent to saying what is the volume of a solid created by rotating this area around the x-axis. So let us draw and the rectangle associated with that, our representative rectangle would be this, because we would be integrating with respect to x. This would be the outside radius. There's no inside radius. It's just a simple disk. The axis of rotation is perpendicular to the rectangle, which means we're using the disk method. Okay, so what we're going to do now is we're going to say, okay, well, if I wanted to use the shell method, what would be different? So the shell, the representative rectangle, is in this direction. It's perpendicular. It's parallel to the axis of rotation. So instead of perpendicular, it's parallel. And we're going to be integrating with respect to y. So that's this direction. We're integrating with respect to y. So what do we need to know? We need to know what the y limits are. So what are the limits? We know the x limits were from 1 to 5. So the inside limit is y equals 0. That's this line. And I had to figure out what this point is. What is the y value corresponding to that? Well, you just plug 5 in. So you'd say y of 5 is going to be equal to the square root of 5 minus 1, which is the square root of 4, which is 2. So our and we're doing it in the y direction. So the shell method in the y direction says the volume is equal to 2 pi, the interval from c to d, of p of y times h of y times dy. So from this stuff we know that c is equal to 0 and d is equal to 2. If we take my rectangle we down here, we run into y equals 0. If we come up to this corner, we get to y equals 2. Okay. So we got the limits. P of y is just y because it's rotating around the x-axis, so it's y. If we were rotating around some other axis, say up here, then it would be whatever that y value was, say 5 minus y. That would be the distance from the axis of rotation. But if it's around the x-axis, it's just, so we know that P of y is equal to y. Now the height of the rectangle is this, so the height of the rectangle is this distance from here to here. So if we take the total distance, which is 5, and we subtract this distance here, which is going to be equal to the y coordinate. So you have to, here the original equation was y as a function of x, so we need to rewrite this equation as x is a function of y. So what do? We square both sides, and we add 1 to both sides. And so our equivalent expression is x is equal to y squared plus 1. So that's x is a function of y, this is y as a function of x. So that's the lower part of the curve. The upper part is x equals 5. That's this vertical line right here. So that's the upper surface, upper part of the rectangle. And the lower part is going to be x is equal to y squared plus 1. Therefore, h of y is 5, which is this distance from here to there, and then we subtract off the distance from there to there, which is y squared plus 1. So that's h of y. So now if we plug everything in, so we're doing the same geometry, which is the volume of that curve rotated around the x-axis. One way using the disk method, and this way using the shell method, but they always give the same answer. We get that. And if you look at the formula, that's the right hand. This is the right hand side, and this was the left hand side. And so that's how you can geometrically prove that they are the same quantity, because they're the same volume, just obtained through different means.